Hello guys, today I'm going to show how to make a simple grid system in C++. First, we are going to begin with creating the C++ class. Let's go to the C++ classes, select new class, and we are going to create a class that derives from actor class. I'm going to name this GridManagement, and our class type is going to be public, so our header file is public and our source file is going to be private. Let's make three variables of type integer 32. The first one is going to be row number, basically how many rows we are going to have. The second one is going to be column number, and the third one is going to be our offset between each grid. I'm going to call this offset. To show these variables in the editor, and if we want to edit them, we are going to use a macro called uProperty. We had to add a specifier called edit anywhere. Basically, this allows that this variable can be shown in the editor and can be edited. I'm going to copy this uProperty macro for all of the variables that we have. Now, I'm going to show the basic idea to make a grid. First, let's imagine that we have a vector that is called span point. First, we are going to loop through our row number. We are going to make an index, let's call it I. Is I less than row number, where the row number is 3? Is 0 less than 3? Yeah. Then we are going to multiply our index by our offset. Offset is going to be 100. 0 multiplied by 100, we are going to get a result of 0. Then our span position.x is going to be 0, which means that the first actor that is going to be spawned, its x location is going to be 0. Then we continue to loop through our columns. This is going to be an inner loop. We make an index k, let's call it k. Is k less than row number? Yeah, I mean column number? Yes. Then we are going to take the span position.y, that is going to be equal to index multiplied by our offset. Index is going to be 0 and offset is going to be 100. And we spawn the first actor in x0 and y0. Then we continue to loop through our columns. Our k index is going to be 1. We multiply that by offset, where we're going to get a result of 100, and our span position.y is going to be 100. Then we spawn an actor in x position that is going to be 0 and y position that is going to be 100. Our index k is going to increase by 1, where the index is now is going to be 2. We multiply 2 by offset, which is going to be 100. We are going to get a result of 200. And our next actor y position is going to be 200 and x position is going to be 0. Then we continue to loop through our row number. Our index I now is going to increase by 1. We are going to multiply our index I, which is 1, by 100, and we are going to get a result of 100. So our span position.x is going to be 100. Then we are going to loop through our column number. Now our k index is going to be 0. Let's multiply 0 by 100. We are going to get a result of 0. So the next actor that is going to be spawned, its x location is going to be 100 and y location is going to be 0. So you get the basic idea. Jump to the C++ file and spawn the grid. We are going to spawn the grid in begin play function. Begin play is called when the game starts or when it's spawned. Now, I'm going to make a variable type of f vector. I'm going to name this span position. And this f vector is going to be f vector.0. Basically, 0 means that each axis of this vector, x, y, and z, is going to be initialized to 0. Then, I'm going to loop through our column number, I mean row number first. Let's make an index, call it I. We are going to check if I is less than row number. If it is, we are going to increment I by 1. Now, because the row number is in x-axis, we are going to take spawn position.x, and this variable is going to be equal to our index multiplied by our offset. So because row number is in x-axis, our actor that is going to be spawned, its x position now is going to be 0. 0 multiplied by 100, or offset is going to be 0. Then we are going to loop through our column number. Let's make an int 32. I'm going to call this index k. Is k less than column number? Then we are going to increment, if it is, we are going to increment k by 1. Now, because columns are in y-axis, we are going to take spawn position.y, and our spawn position.y is going to be equal to k multiplied by our offset. Now that we have our spawn position.y and spawn position.x, we are going to spawn the actor. To spawn the actor, we need to get the world. To get the world, we are going to type get world. This returns a uWorld. uWorld is a class that contains all the actors and components that exist in our sandbox and that will be rendered. This class has functions like spawn actor, line trace, sweep trace, etc. etc. We are going to use spawn actor. Spawn actor takes 3 parameters and a template specifier. First, we have to declare the template specifier. A template specifier basically is a specifier to specify that which class is going to be spawned. In our case, it's going to be actor class. Now the first parameter has to be a tsubclass. Let's declare this variable in our header file. It's going to have the uProperty macro. This subclass of a actor is going to be actor class. Let's call it spawn actor class. This subclass helps us to select which class we want to be spawned. Because we declare here an actor class, every class that is derived from actor class is going to be shown in our editor. Let me show this. We have error. I'm going first to delete this. Now, let's make a grid management blueprint. Let's call this BP grid management. I'm going to place to the content file. Now, here, as you can see, we have the spawn actor class. If we click here, we are going to see all the blueprints that derive from a actor class. If here we make, let's say, a grid management, every class that derives from a grid management is going to be shown here, like this. Now let's make this actor. Now let's get the world, use the spawn actor function. Let's specify the template is going to be a actor. Remember that the template specifier has to be same as our tsubclass. Our first parameter is going to be the spawn actor class. The second parameter is for our spawn position, which we declared here. And our third and last parameter is the rotation. I'm going to get this actor's rotation by typing get actor rotation. Let's compile this. Let's make a blueprint actor class, which this class is going to be a temporary class. Let's select actor. I'm going to name this actor class. This class is going to have a static mesh. I'm going to give a cube static mesh. I'm going to scale it down this by 0.3. Then in our grid management, I'm going to select the actor that we created, which is BP actor class. The row numbers is going to be 3, the column number is going to be 3, and offset I'm going to make, let's make it 100. Now let's put our BP grid management into our world. I'm going to set its positions to 0. When I press play, you can see our grid has spawned. In the next video, I'm going to make a class called grid representative. Instead of using BP actor, we are going to use BP representative. Thank you for watching, guys. See you in the next video.